Hi, in this video we are going to see about a semaphore. So semaphore is a kind of a concept where it is used in process synchronization. So we are going to that is it is helps to manage the current concurrent process and scheduling the process. So under the semaphore, we are going to see a problem called a dining philosopher. So here you see that here there are five philosopher. So one, two, three, four, and five philosopher, and each five folks. So the philosopher has a two state. One is thinking state, and another one is a eating state. So thinking while the philosopher in the thinking state, he will think, and while in eating state he will eat. By while in eating state he uses this fork to that is for uses his fork, and it will he will eat that served rice or noodles that is served for him. And philosopher, while in eating state he will be eat. So in that state he will use both the forks, that is one, two is left, that is one, and two is right, two. So he need two chopstick or a fork to eat. So so in this case, if you consider the philosopher as a process, so you take one, two, three, four, five. So there are five process, and the forks or the chopsticks or the resources. So the process need to use this resource. So which in what order? So we can use this resource. That is the concept of using this dynamic philosopher. So before going to this, implementing this, let us see this semaphore. So the semaphore has a two state, that is waiting state, that is P, and signal state, that is V. So waiting state. So if you consider a process, that is if you take P1, P2, if you take three process P3. So now let us take three process. This three process need to use a resource. So need to use a resource. First the P1 has a some value. So the semaphore remains is not a thing. The semaphore is a one kind of a integer value, non-negative integer value. So through this non-negative integer value, this whole semaphore concept is going to arrive. Sorry, control. So this value is passed through different threads, and by using this value, we can that is we can schedule the process. So if that is P, so S is the semaphore. This is the S is the value. That is S is a value. So if you take that is semaphore, S is a value, while S is equal to, that is equal to 0, it will wait S equal to 0. So what it will do, that is wait until S equal to 0. So if S equal to 0, then it will make S equal to S minus 1. So it will make S equal to S minus 1. Otherwise it will be note that there is a semicolon after a while. This code gets stuck here while S is 0. So see here, while S equal to 0, so that means while the loop will, this is a loop, that is while S equal to 0 means it will be in the loop. Here there is no, that is the body of the while loop will be blank, so it will be get executed in the while loop, so it will be get stuck. So that is the process P1 is in a waiting state. So that is when S equal to 0. When S is not equal to 0, or whether it is less than or sorry, it is cannot be less than 0, it is greater than 0. If it is greater than 0, then S equal to then it will perform this s equal to s minus 1. This expression will be performed and it will be signal. So the after it will be signal and it will make s equal to s plus 1. So now let us take one process, that is p1. So three process, there will be the state will be now initially we take as 1. So now the P1 is a process, it go inside. So now yes, this is the semaphore for that. So for that process, so now s equal to state equal to 1. So it will be fail and it will go next state. So s equal to s minus 1. So it will make the state as 0 now. So if it is 0, it indicates that P1 is using the resource. So at the time when at the time the P1 is using this resource, at the same time the P2 get inside the resource, what will happen now? The state is 0. So now s equal to 0. Now what will be? It will be stuck in the while loop. So it will get stuck. If P3 comes inside, it will also get stuck because the state equal to 0. While P1 is using the resource. After using the resource, so it will be used this it will be throw this expression and it will be used this resource. After using the resource, it will this signal. So it will call this function. So it will call this function, that is called a signal. So it will signal means, so it will make s equal to s plus 1. So s plus 1 means plus 1. So now a state equal to 1. Now process 2 will be get executed. So process 2, it will be stuck. So once it is state is 1, state it becomes 1. Now s will is the while condition will be fail and it will go comes out of the while and it will make this statement. Now s equal to 0. Now p3 will be get stuck. So same by this process, the process may be signalized. So this is the semaphore. This concept we have been using in the dynamic philosopher. So same for philosopher, there are 5 philosopher and 2 folks. So 2 folks, the philosopher should use 2 folks. Then only he can use this resource that is served to him. He can be used. So same in this there are 5 process and you resource to use resource they need 2 folks. So it can be now state can be you taken as now state making make a may take may be taken as 2. Now let us reduce if 2 minus 1, so 1. Now 1 resource 1 minus 1 0. So if the state is 0, the process is being used. The another the nearby philosopher who are angry need to wait until the this philosopher one is until he completes, that is alternative philosopher, this 3 2 and 3 2 and 5 philosopher need to wait. The 4 and 4 and 3 and 4 philosopher can be use this folk, that is they has two folks to alternative to them. He can use whether any one of them can be used at that time. And after the philosopher completes, the next philosopher can utilize the resource. So that is the dynamic philosopher. So now let us implement this code, that is I have used in a C program, that is int tpk is the total philosopher and philosopher name I have taken is 20. Status is in array and how many are them are hungry, then hu, then choice. So in main functions you have here this is dynamic philosopher. Now enter the total philosopher, they will be entered. So up to total philosopher the array will be, so now philosopher 1 will be 1, 2 will be 2, 3 will be 3, 4 will be 4. The status of all them will be 1. So status of all them will be 1. Now print how many are hungry. So now how many are hungry, it will be getting from the users. Now let us take if there are 5 philosopher and hungry or 5 philosopher means, so if you see here if you see here, there are five philosophers. Totally there are five philosophers, and if you make if you give the who are hungry, if you take five philosophers, then he will take the left chopsticks to the philosopher. The philosopher will make a use of left chopstick. So the chopsticks will be the chopstick will be it will be fulfilled. That is, all the philosopher make use of this chopstick. So one philosopher need two chopsticks to utilize the resource. So all of them having now one, and until everybody has one, now no one is ready to use this resource. So it will be stuck in this case, and it will be occur a deadlock. So in this case, the number of stock, that is how hungry is if equal to total number of philosopher. In this case all are hungry, deadlock will state, deadlock state will be occur. Now it will be exit, and now that is the thing. Otherwise, if how many members are hungry, that is less than the total philosopher, it will be so here, next in else condition, that is if how many philosopher enter the position, that is position it will be take, and in it will be stored in hungry, and the status of that hungry, the hungry philosopher, the status will make us two. Initially it will be in one, the hungry that is the hungry status of the philosopher will make two, and now and the one can eat at a time, then two can eat at a time, and the three is exceed. So these are the condition we can make use of that. Either only one can be eat at a time, or two can be eat at a time. So now let us get the choice, and according to that make the function. So if it is 1, position equal to 0, x equal to 1, now allow one philosopher to eat at a time. So in for loop we will make the one philosopher, that is it is now the first given position will be granted to eat, that is the position will be get from the user, and it will be and that hungry to position will make to eat. And after that now next that position, and it will be after that position who are the you have given that they will be waiting. So next the position will be incremented. Next the next member will be granted to it. Next to the position, next to the philosopher will be waiting. So in this case the one by one will be granted to it. So next is 2. So in that 2, there are first allow 2 philosopher to eat at time. So same here, instead of one for loop we are getting 2 for loop. So for I equal to 0, how many are hungry? So from j I plus 1 hungry up to hungry abs, that is hui minus huj. So it will be minus, that is a thing, and if it is equal to 1, and that is absolute this, then combination of d will be equal to, that is combination is s plus 1, that is t equal to h of I. The agreed that I position will be stored in t, and j will be stored in r. Then it will make s plus plus. Now it will be print according to that combination. So now let us execute this code. Here philosopher dining. Now let us take total philosopher as 5. Now let us take 3 as hungry. First position is 2. Second position is 3. Third position is 1. So 1 can eat, that is P1. So P3 is granted to eat. Then P3 will be waiting, and P4 is waiting. P0 is waiting. P4, now next P4 will be eat. Next P5 will be waiting, and P0 is now eating, granted to eat. So now let us give 2. It will be that is combination 1 or P3 and P4 are granted to it, P0 is waiting. Combination 2 or P3 and P0 are granted to it, P4 is waiting. Combination 3 or P4 and P0 are granted to it, P3 are waiting. That is the thing we have been made, and if you give 3 it will be exited from the program. So that's it from yes. Thank you.